energy. So chemistry is concerned a great deal with matter, but we're also concerned with energy, because energy is often involved when matter transforms or undergoes chemical changes. So what is energy? What we'll find is that there's some words that we use in chemistry slightly differently than how we use them in everyday life. In science, energy is the capacity to do work. I have the potential, I have the ability to do work. Well, what is work defined as? Work is the action of a force through a distance. That's different than what we define work as in everyday life. Work in everyday life usually involves being paid money to do something, right? If I push my Sharpie marker across my desk, I have applied a force through a distance. I just did work. What'd you do today? Oh, I worked all day long. I just pushed my Sharpie marker back and forth on my desk. I was working really hard. It's work. It's just not work that your mom would understand, right? You push a box across the floor. Now, there are people who get paid to push boxes, right? So they're like doing double work? I don't know. But here's this guy. He's pushing a box. He's applying a force through a distance. That's what work is. The physicists are a lot more concerned about that. When you ride your bike, you pedal your bike across the street. When you're walking, you are doing work in the scientific sense. Energy is the ability to do work, right? We divide up energy into different categories. Kinetic energy is energy associated with motion. And potential energy is energy associated with position or with composition of an object. So here we have, on top of this building, a 10-kilogram weight. Who would put a 10-kilogram weight on the edge of the roof of a building? This is almost like the cartoons, right? And they're always hanging the piano out the second floor window. This is unstable. You give that a little bump, and it's going to fall. It has the potential to fall. It has potential energy because it's high up on top of this building. The higher something is above the ground, the higher the potential energy that it has. We push this off, and that potential energy gets transformed into kinetic energy as this weight moves faster and faster. The faster an object is moving, the more kinetic energy it has. When it hits the ground, what happens to all that energy? It gets dissipated as heat. And would you want to be underneath that when it came down? I wouldn't. No, that would be painful. There's a lot of energy with that moving object. And when it hits the ground, the energy does not disappear. We don't necessarily see it, or we can't necessarily detect it, but it does get transformed into heat energy. If you've ever used like a power drill and touched the drill bit after you've drilled a hole, it's hot, right? If you move things, it's not going to, those analogies aren't going to be very good. So we have the law of conservation of energy. So this is a statement of what happens, doesn't explain why, just says this is what we have observed. Energy is conserved, meaning it is neither created nor destroyed. So we can change energy from one form into another. Energy can flow from one object to another, but the total quantity of energy is constant. So the total content of energy is the same. Objects with high potential energy tend to be unstable, meaning they're likely to come down in potential energy and release that potential energy as some other form of energy. Chemical energy is a form of potential energy. Here it's not due to position, like a weight raised above the ground, but it's due to composition, the position of the atoms relative to each other. and the forces of attraction and repulsion within them. Thank you, Dropbox, for informing me. So if something has high chemical potential energy, it is also likely to be unstable. Gasoline has a fairly high chemical potential energy. It's unstable. If you spark anything in the presence of gasoline vapor and oxygen, kaboom, it's going to blow up. Now, if you do that with water, will the water explode? Nope. Water has a lower chemical potential energy than gasoline does. TNT is another high potential energy substance. It's unstable. So in chemical changes, we cannot create or destroy energy. Now, we're not talking about nuclear processes. That's a different thing here. We're limiting to chemical changes or to physical changes. So if you have a system with a high potential energy, it's going to have a tendency to change in a direction that lowers that potential energy by releasing energy into the surroundings. If you think about your car, the molecules in the gasoline in the gas tank have high potential energy. They're unstable. And when you run them through the engine and you react them with oxygen, they release that chemical energy. And they cause the pistons in your engine to move, and they cause your car to move forward. Does all the potential energy from the gasoline translate into movement of your car? No, it doesn't. It'd be awesome if we could do that, 100% efficiency. What happens to the temperature of your engine as it runs? It gets hot. Where's that heat coming from? That's some of the potential energy from the gasoline that escapes into the atmosphere, basically. It's not used for the purpose of moving the car, but it's released. The sum of all the energy released as heat and as motion of your car would be equal to the potential energy that the gasoline had before. But some of it gets lost. We say it's lost, but it's lost to usefulness. It is actually still there. It is conserved.